Welcome to doassignment-ca. Here is the problem. A hockey puck is traveling to the left with a velocity of v1 equals 10 meters per second when it is struck by a hockey stick, and given a velocity of v2 equals 20 meters per second, directed at 40 degrees above the horizontal to the upper right. Determine the magnitude of the net impulse exerted by the hockey stick on the puck. The puck has a mass of 0.2 kilograms. Now, let us work through the solution step by step. We apply the impulse momentum principle. The net impulse vector j equals m times v2 minus m times v1, treating these as vectors. The mass is 0.2 kilograms. We define positive x to the right and positive y upward. The initial velocity has only a negative x component of minus 10 meters per second and 0 in y. The final velocity is directed 40 degrees above the horizontal to the right, so its x component is 20 cosine 40 degrees, which equals 15.32 meters per second, and its y component is 20 sine 40 degrees, which equals 12.86 meters per second. Multiplying each velocity vector by the mass of 0.2 kilograms, the initial momentum is negative 2.0 in the x direction and 0 in the y direction. The final momentum is 3.064 in x and 2.572 in y, both in Newton seconds. Subtracting the initial momentum from the final momentum component by component, the x impulse is 3.064 minus negative 2.0, which equals 5.064 Newton seconds. The y impulse is 2.572 minus 0, which is 2.572 Newton seconds. The magnitude of the impulse is the square root of 5.064 squared plus 2.572 squared, which equals the square root of 32.259, giving approximately 5.68 Newton seconds. Checking both components confirms our work. The direction of the impulse is the arctangent of 2.572 divided by 5.064, which is approximately 26.9 degrees above the positive x-axis. The net impulse exerted by the hockey stick on the puck has a magnitude of approximately 5.68 Newton seconds directed to the upper right. This makes physical sense because the stick both reversed the puck's leftward motion and redirected it upward and to the right. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.